Yes. So let us move again. The fluid mechanics is the today topic, and in this fluid mechanics, we will try to discuss the fluid viscosity, streamline flow of liquid, profile of the liquid flow, Reynolds number, Bernoulli theorem, and etc. So if we talk about the fluid, so we can classify fluid in two categories. First is Newtonian fluid, and then second is non-Newtonian fluid. So what is Newtonian fluid? The fluid which obeys the Newton's law of viscosity. Newton's law of viscosity is known as Newtonian's fluid. So what is Newtonian's fluid law? That is, shear stress is proportional to velocity gradient. What is velocity gradient? For velocity gradient, if we consider the flow of liquid, मान लीजिए ये liquid का flow हो रहा है, तो इस liquid के flow में जो नीचे का layer है उसकी velocity हम आप देखें तो जैसे जैसे ऊपर चलेंगे V1, V2, V3, V4, तो velocity बढ़ता हुआ होता है. तो ऊपर जाने से वेलोसिटी बढ़ रहा है ना. दिस इज जेड एक्सिस, दिस इज योर जेड एक्सिस, एंड हियर इट इज द चेंज इन वेलोसिटी. सो डीवी बाई डीजेड इज नोन एज वेलोसिटी ग्रेडियंट. दिस इज वेलोसिटी ग्रेडियंट. अब इसमें कोई भी एक लेयर है उसको रिफरेंस लेयर मानते हैं. सो टेक V3 as reference layer. V3 as a reference layer. तो V3 के जस्ट ऊपर जो लेयर है V4, वो लेयर इस V3 लेयर पर एक फोर्स लगाएगा, दैट इज FF. FF इज क्या है? फॉरवर्ड ड्रैगिंग फोर्स. दिस इज फॉरवर्ड ड्रैगिंग फोर्स. और V3 रेफरेंस लेयर के जस्ट नीचे का जो लेयर है V2, वो इसके ऊपर जो फोर्स लगाएगा वो FB. व्हाट इज FB? दैट इज बैकवर्ड ड्रैगिंग फोर्स. ठीक है, दिस इज फोर्स. तो इस फोर्स के वजह से देयर इज ए वेलोसिटी डिफरेंस, और ये वेलोसिटी डिफरेंस के वजह से इस पे लगेगा एक शियर स्ट्रेस. तो शियर स्ट्रेस टाउ को हम लिख सकते हैं, दिस शियर स्ट्रेस टाउ इज डीवी बाई डीजेड. ये शियर स्ट्रेस टाउ, या इक्वलिटी कर दें तो दिस इज एटा इंटू डीवी बाई डीजेड. और ये जो शियर स्ट्रेस है, शियर स्ट्रेस माने फोर्स पर यूनिट एरिया. शियर स्ट्रेस इज फोर्स पर यूनिट एरिया. तो इफ वी टेक द फोर्स F, तो F इज इक्वल टू ये दिस इज शियर स्ट्रेस इंटू A. तो दिस F इज इक्वल टू A इंटू एटा इंटू dV by dz. So this F is viscous force. This is known as viscous force, and the proportional coefficient F is the viscous force, and the proportional coefficient eta is known as, this is coefficient of viscosity. So this is the Newton's law. And when the liquid follow this law, then we call it is the Newtonian fluid. This is Newtonian fluid. And then it is non-Newtonian fluid. Non-Newtonian fluid. How to describe the fluid the fluid viscosity change at different fluid density. And velocity. That is, fluid does not flow as the Newtonian way. So what we find here, this the shear stress tau is dV by dz, and and the fluid depends upon the rate of flow, as the different thickness. So first is shear thinning. First is shear thinning. What is shear thinning? When the liquid of fluid, when the viscosity of fluid decrease with the increase of shear rate, then the fluid is known as shear thinning. For example, blood is non-Newtonian fluid, while water is Newtonian. Paint, polymer, etc. So what we mean is when the viscosity is decreased with the increase of shear rate. shear rate कम बढ़ाने से viscosity कम हो रहा है. So this is shear thinning, and the most important example is blood. And second is shear thickening. When the viscosity of fluid increases with the increase of shear rate, then the fluid is known as the thickening, shear thickening. For example, a mixture of starch, water, printer ink, mud, etc. So we can have the graph as graph is, suppose this one is shear rate. This is shear rate. So this is the shear thickening, because here it is the coefficient of viscosity, which is the positive. This is 0. And this is the shear thinning. Shear thinning example was blood, paint, and polymer. And shear thinning is starch, printing, ink, etc. So these are the example of non-Newtonian fluid. And with this non-Newtonian fluid, we can quickly explain the Reynolds number. This Reynolds number K defines the ratio of, it is defined as the ratio of, K is ratio of internal force upon viscous force. Internal force upon viscous force, that is rho V into D upon eta. And if this value is 1000, then it is laminar flow. If its value is 2100, 2000 and above, then it is critical flow. And if it is greater than 2001, then it is called as turbulent flow. So this one is the importance of the Reynolds number. It is just a ratio which has internal force upon viscous force, and internal force is density, velocity, and this D, and viscous force is eta. And then we can have the empirical value, that is, if it is 1000, then it is laminar flow, streamline flow, or 2000, then it is critical flow. And if it is more than 2100, then it is called the turbulent flow. So this is about the Newtonians, non-Newtonian, and viscous force. So